See if that comes out okay. All right, first thing we're going to do, now look at number 2. You got to compute a 4x4 determinant, but there's no zeros. Mr. Park, last night's homework had at least 2 zeros in one column. What if there's no zeros? Then either you got to do plenty work or you got to use theorems. So let's look at the theorems in the notes. Okay, where is that? There's 11 pages of notes. There it is. Okay, properties of determinants. What page of this? That's page 3 of the notes on the bottom. You probably want to follow along. Okay, now these are properties to help you compute like a 4x4 determinant. Okay, read the first one. Now, with these properties, things work in rows. You can go row with row, or you can go column with column. So it's not just row, but you cannot go row with a column. It's a row with a row or a column with a column. So read the first one. If one row, I'm not going to even read the column part. If one row is a multiple of another row, then the value of the determinant is 0. Now that's easy to see. Like if you look at a 2 by 2 determinant, okay, stay in the middle there here. Like if you have 2, 3, what would be a multiple of 2 and 3? Okay, give me a single digit number. 6. Okay, multiply by 6, that would be 12 and 18 then, right? Isn't the second row a multiple of the first row? And when you compute the determinant, look, you get 36 minus 36 is 0. So if one row is a multiple of another row, or one column is a multiple of another column, the determinant is automatically 0. You don't even have to compute. So for example, what if you look at a 3 by 3? How about this? 1, 2, 3, 7, that's not 7. 7, 6, 2, 2, 4, 6. Without doing any work, that is 0. How come? Because this row is a multiple of that row. And if you want to compute it, go ahead, it's going to come out 0. And then, it could be like this. What if you had 1, 2, 3, 2, 7, 9. What the heck am I doing? Sorry. 2, 4, 9, 3, 6, 10. You look at that and go, that's 0. You know why? Because this column is a multiple of that column. Now, sometimes it's hard to see, but then sometimes it's not. Like, for example, on the second quiz, you might have determinants where there's no numbers, there's only letters. But then that makes it easier to see the multiples as well. Okay, so if everybody understand what I'm talking about? You can go row with a row or column with a column. Okay, look at the next property. If one row is multiplied by a non-zero constant k, then the value of the determinant is multiplied by k. Okay, so look at this. Give me some numbers. 3, 4, 5, 6. What is the determinant? Come on, this is 2 by 2 people. This times this minus that times that. Negative 2, thank you. Okay, give me a non-zero number.
1.
Okay, that's not 1.
2.
Okay, 2. Okay, you want to multiply a row or a column, it doesn't matter.
Column.
Okay, let's multiply the first column by 2. So that's 6 and 10. The other column stays the same. What do you have now? 36 minus 40. Really? 36 minus negative 4. See, I multiplied this column by 2. What happened? The determinant got multiplied by 2. So if you multiply a row or a column by a number, the determinant gets multiplied by that number. Here's a good problem. You might see on the second quiz, but then I would have to change it. I'm gonna try and squeeze it in here. If A, see, like, there's no number, see, this kind of problem tests to see if you know the properties. D, E, F, G, H, I. If this is equal to K, what is the value of 2A, 2B, 2C, 2D, 2E, 2F, 2G, 2H, 2P? What is that equal to? Fill in the box.
2K.
No.
6.
Okay, let's read the property again. If one row or column is multiplied by a number, then the determinant gets multiplied by that number. Okay, so what's the answer? 8K is the answer. What? Because look, that row got multiplied by 2, so you multiply by 2. Here's another row got multiplied by 2, so you multiply by another 2. And there's another row that got multiplied by 2, so you got to multiply by another 2. 2 times 2 times 2 is 8. You see that? So if you multiply a row by a number, the determinant gets multiplied by that number. Okay, third one. If 2 rows are interchanged, or 2 columns, then the value of the determinant gets multiplied by -1. Okay, so let's look at this one. Look at this. This determinant is -2. Okay, now, do you want to switch the 2 rows or the 2 columns? It doesn't matter, it's fine. Tell me. Rows or columns?
Row.
Okay, row. Here are the 2 rows. What would happen if you switch it? 5, 6, 3, 4. Okay, now compute it. 20
2.
minus 18 is 2. See how the determinant got multiplied by -1? So if you switch any 2 rows or any 2 columns, the determinant gets multiplied by -1. All right? So I guess, what's the problem might we give? Okay, if I give you this, then what would this be? A, B, no, yeah. A, B, C, G, H, I, D, E, F. So if this is equal to K, what is this equal to then? Answer is -K because I switched these 2 rows, which multiplies it by -1. And then the last one, this is probably the most important one. If a row, I'm not going to say column now, if a row is multiplied by a non-zero constant and then added to another row, the determinant does not change. It stays the same. Okay? Now what does that mean? Well, here, look at this. So this determinant is -2, right? Okay, watch what I'm going to do. I'm going to erase this so we can stay close. So, first of all, pick a row or a column. It doesn't matter. Pick any row or any column. Okay, first row then. Okay, you see this first row? I'm not going to change it. Just leave it. Now, pick a non-zero number.
3.
Okay, 3. What if I were to multiply this row by 3 and add it to the other row? Okay, multiply this by 3. Can we do this in your head? And then add it to that.
14.
14. Multiply this by 3, add it to that. You get 18. What's the value of the determinant now?
2.
54 minus
56.
56.
15.
Okay, some of you going, wait, I can't do the 54 minus 56. That's -2. See, it's the same. It didn't change. Some of you going, so what? Well, you'll see why this is important in a minute. Yeah, but Mr. Park, you said you can do it with columns. Yeah, okay, pick which column you want to do, first column or second column. It doesn't matter, that's fine.
First.
Huh? Who said third?
First.
Okay, first. Okay. Here's the first column. Don't touch it. Now, think of a number. 2. Multiply this column by 2 and then add it to this one. Multiply that by 2, add it to that.
10.
Multiply this by 2, add it to that.
16.
Okay, compute the determinant now. 48 minus 50. Yeah, that's -2. It didn't change. It stayed the same. Okay, why is that important, Mr. Park? Well, because on tonight, in fact, not on tonight's homework, on the next quiz, you're going to have to compute several 4x4 determinants and not going to have any zeros in them. So what do you do? Well, I'll tell you what you should do. Now, when you have a 3 by 3 determinant, you can do this technique I'm gonna show you now, but I don't think it's worth it. But when it's 4 by 4, it's definitely worth it. Okay, so here, gotta squeeze it in here. Okay, give me some numbers and let's keep it small. In fact, let's do the same one we did last time. Okay, wait, let me think. I did 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then I think I did a 2 there, yeah? What did it come out to though? Negative 48? No, I can't even remember. That's okay, we're gonna get it. Okay, compute this determinant. Now, if you want to, you can go across the first row and then you gotta compute 4 3 by 3 determinants. How long do you think that'll take you? Well, if you practice, you can do it in less than a minute, right? Okay, less than 2 minutes. Okay, but watch what I'm gonna do. Mr. Park, if there were zeros over here, then I would be in the money. But I don't see zeros, so then let's make zeros. This is called generating zeros using that fourth theorem over there. So watch. So the key is you gotta look for a 1. Now you don't have to look for a 1, but if you don't use a 1, then that means you're gonna have to use fractions. And you guys know how you are with fractions and negative numbers already, right? So the SAT people, they know what they're talking about, right? When the SAT people write problems, you know how they make it harder? They either put fractions or negative numbers in there. And it usually works. Okay, I see a 1 here, 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 and here. You can pick any one of those ones, and you can pick it in the row or the column. It doesn't matter. Okay, I'm going to use this one here in the first row. I don't know. Okay. So the first row, you don't touch it, just like we did over there. You don't touch it. You got to pick one row or column. Don't touch it. Now, your goal, I'm going to use this 1 to make zeros here, here, and here. Because then if you have 3 zeros in a row, instead of doing 4 3 by 3 determinants, you only have to do 1 3 by 3. Isn't that better? I don't know what you're saying, Mr. Park. Well, okay, let's just do one thing at a time. Okay, now, look at this first row. What do I need to multiply this 1 by? So when I add it to this, you get 0. Negative 2, but you got to do that to the entire row. Okay, so here we go. Multiply by negative 2 and add it to this.
0.
Multiply by negative 2, add. Multiply by negative 2, add. Multiply by negative 2, add.
0.
That's called a bonus 0. We didn't expect that to be 0, but it is. It's just a bonus then. So, why did you do that, Mr. Park? Because I got a 0 there. The more zeros, the better. Okay, now I'm gonna change this 3 into a 0. So, what do I need to multiply this by? So when I add it to this, you get 0. Negative 3, but you gotta do that to the entire row. Multiply by negative 3, add. 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 That's a bonus 0. I was just lucky that one came out 0. And then finally, I want to get another 0 here. So what do I need to multiply this by? So when I add it to this, you get 0. Negative 1. So multiply by negative 1, add. Multiply by negative 1, add. That's a bonus 0. Multiply by negative 1, add. Ooh, another bonus 0. Multiply by negative 1, add. So, according to that fourth theorem, the value of this determinant is the same as that one. But which one is easier to compute? This one, because you have a plethora of zeros. So now you can take your pick. You want to come down the first column, you want to go across the fourth row, you want to come down the fourth column, but this one only got 2 zeros. 3 zeros is better than 2. But anyway, like I told you, these are bonus zeros. Those are lucky it came out to 0. So I'm going to come down the first column. Now, is this a positive or a negative position? Because don't forget that, and that's really important. Plus, minus, right? Or if you come down the column, it's going to be plus, minus, plus, minus. So is this in the positive or a negative position?
Positive.
It's in the positive position. The upper left hand is always positive, right? Because 1 plus 1 is 2, right? Okay, so it's going to be plus 1 times something, minus 0 times something, plus 0 times something, minus 0 times something. Well, we don't care what these are because those are all zeros. All you care about is this one. So like I said, instead of computing 4 3x3s, you only have to compute 1 3x3. It saves you a whole bunch of time. Okay, so how do I get what's in here? Remember, you cross out the row and column that it's in, and you get -1, -5, 0. -5, -7, 0, 0, 0, 1. And it's lucky we get bonus zeros now, because which row or column would you pick to compute this?
Last row.
Either the third row or the third column, because it got 2 zeros, right? So which one you want to do?
Third row.
It doesn't matter, because remember, pick any row or any column. Okay, let's go across, since we came down the column, let's go across the row. So is this the positive or the negative position? Positive, so it's going to be 0 times something, minus 0 times something, plus 1 times something. Now, we don't care about these because 0 times anything is 0. So all you care about is this. And what is that? 7 minus 25.
Negative 18.
Negative 18 times 1
Negative 18.
times this one.
Negative 18.
The answer is negative 18. Yep, I remember that's the answer, yeah? So, this is what you're going to do. You got to practice doing this technique on the homework. Because now, normally on the test, problem number 1, you have to compute 5 4x4s. But we're not going to have a test on this, so I'm probably just going to give you 1 or 2 4x4s to compute, or at least 1. Mr. Park, I'm just going to take the hit on that problem. This is not hard. You just got to practice it. It's just like jumping rope. Okay, what's the next thing I got to teach you? Kramer's rule. Now, Mr. Cropsey, who had Mr. Cropsey last year? It's already confirmed. You guys learned Kramer's rule last year, right? Does that sound familiar? Kramer's, oh my goodness. Now that class has already confirmed it, people. How about that? Maybe if I write it out. Kramer's rule. Named after the mathematician Gabriel Kramer. Okay. Anyway, I believe you guys did 2 equations, 2 variables last year with Kramer's rule. This year we're going to go 3x3 and 4x4. Okay, let me show you how Kramer's rule works with 3 equations, 3 variables, but it also works for any equations and variables. Okay, so give me 3 equations. Let me erase the dartboard. We're going to start from scratch. Kramer's rule. Okay, so this is one application of determinants. This is why we study determinants. Kramer's rule. Okay, give me 3 equations, 3 variables. X plus 2y plus 3z is equal to, give me a number. 5. 2x minus y minus z equal, give me a number. Oh, daring, huh? 3x minus 2y plus z equals, give me a number.
3.
3. Okay, let's see how good you guys are. Does it come out nice or does it come out ugly? See, when I make my problems, I make them come out nice. Okay, does this sum, now, of course, if you had Mr. Rubash, you didn't, even no bonus quiz, optional quiz? Well, it doesn't matter, teaching you know. So D is the determinant. 1, 2, 3, 2, negative 1, negative 2, 3, negative 1, 1. Where did I get these numbers from? The coefficients of the variables. In fact, think of this as the x column. These are the coefficients of the x's. These are the coefficients of the y's, and these are the coefficients of the z's. So we call this determinant D. Okay, now watch what I'm going to do. Now I'm going to compute D sub x. D sub x, now, okay, well, I'm going to do it, and then you tell me what I did. 5, negative 1, 3, 2, negative 1, negative 2, 3, negative 1, 1. What did I do?
Inverse fit.
I took the constants, you see these constants right here? And what did I do? I put them here. Remember I told you, think of this as the x column, the y column, and the z column. So d sub x means take the constants and put it in the x column. That's what I did. Everything else stays the same as the original. This is the original. D sub y now. What do you think? If you had to take a guess. What is d sub y? You take the constants and you put them in the y column. Everything stays the same from the original. Everything else, rather. And then what do you think d sub z is? Take the constants and put it in the z column. Everything else stays the same as the original. Okay, now what you have to do now is compute these four determinants. Okay, we're gonna practice. You're gonna have several of these on tomorrow's quiz. Again, we're gonna practice. Okay, d sub x, d sub y, and then d sub z. Go! Let's see if we can do one in the time it takes me to do four. Hopefully I won't make a mistake this time. My brain is foggy. Okay, d. Did d come out to negative 20? 10. Just nod your head, maybe hold 5
I'm
pounds.
still trying to do it in my head.
Oh, you can do it in your head.
Oh no, because my iPad died.
What, no such thing as paper and pencil? Now what? I'm not gonna reach down for that. Okay, what about d sub x? D sub y? Come on, somebody d sub y. Do you? Okay, never mind. D sub z? Okay. I'm just assuming I did it right. But knowing me, I probably made a mistake. So, what are you trying to find when you solve 3 equations, 3 variables? You're trying to find where these 3 planes, these are each planes now. When you solve 2 equations, 2 variables, you're solving where 2 lines intersect, right? 3 equations, 3 variables, 3 planes. Where do the 3 planes intersect? When you solve 4 equations, 4 variables, where do the 4 hyperplanes intersect? Well, the answer is d sub x over d, d sub y over d, d sub z over d. And for those of you who learned Kramer's rule last year, is this bringing back memories? Okay, so what's the answer? What is the point where these 3 planes intersect? What is d sub x over d?
1/5.
1/5. Oh, God. See, you guys pick wrong numbers. D sub y over d. Negative 1/5. I guess it could be worse. And then d sub z over d. See what happens when you get fractions?
3/5.
3/5. 3/5 or 3/4? 3/5. What are you talking about? And there you go. That's the point where those 3 planes intersect. This is called Kramer's rule. So, if we had a test, the very first problem would be solve 4 equations, 4 variables. Tell me what you would have to do. How many 4x4 determinants would you have to solve? 5. D sub w, d sub x, d sub y, and d sub z. That's problem number 1. You would have to compute 5 4x4 determinants, and that's just number one, and then you got 7 more problems to go. But you're not gonna have a test, so I'm probably gonna just make you, maybe I should just make you compute just one of them, like either W, X, Y, or Z. How's that? That's what you're gonna get. Okay, finally, last thing. Oh. How am I gonna get through today? I had to pick up 2 more classes because one math teacher went on leave. So I had to pick up 2 more classes. It's killing me. Luckily, I'm young and have a lot of energy. Oh. Okay, so how do you compute the inverse? Okay, we know how to find, okay, tomorrow's quiz. You guys better know how to find the inverse of a 2x2. In fact, let's review. Matrix A is, give me how about the 4, 5, 6, 8? How do you find the inverse? Should I do the ABC method, or is there a theorem that we learned? Yes, please use the theorem. It's a lot faster, people. What's the theorem? 1 over the determinant of this, 32 minus 30.
2.
2. And then, what do I do with these two? You switch those two and negate those 2. There you go, that's the inverse. Now, do we have a shortcut like this for 3x3 and 4x4 and 5x5? Yes, well, it's shorter, but it's not as short. I mean, it's shorter, but at least it's better than doing the ABC method, right? Remember, you have to go A, B, C, D, E, F, G, H, I. There's gotta be a better way. Okay, so let's do one. What if A, so what you gotta do is you gotta look at the notes, plus in the problem on tonight's homework, I take you by the hand and lead you through it. Okay, give me some numbers. 2, 3, 5, 4, 2, 1, 3, 1. Give me a number. What?
3.
I heard 2 first. No, but I like 3, because look, it's in the triangle right there. But then if it was a 2, then you come, never mind. Okay, find the inverse. Now watch, you gotta pay attention now. So, one way you could do it is the ABC way, but I don't think anybody wants to do that, because we have to do it on the homework, right? How long did it take you to solve those 3 sets of 3 equations, 3 variables? Mr. Park, I didn't do it. I'm waiting for you to teach me the shortcut. You guys are. Okay, watch what I'm gonna do. I am going to replace each, how many elements are there here? 9. I'm going to replace each one with its cofactor. What's a cofactor again? It's the minor multiplied by either 1 or -1. Now remember, which ones are in the negative positions?
3.
Okay, here, you know what? These are the negative positions. So I'm gonna put the -1 there already. So put the -1 there before you even start. Now, remember what the minor is? That's what you get when you cross out the row and column. So this element here, if you cross out the row and column, like this thing, for the camera, what's the determinant of what's left?
4.
6 minus 1, 5. And you just keep on doing that, filling it all in. Okay, give me the ruler. Give me the ruler. That's it, I'm going to use the big ruler. Okay, what about this element up here? Cross out the row and column. What do you got? 12 minus 3. 9. Oh, this is will be. What about this one? 4 minus 6.
-2.
Who said bring up this stupid ruler? Okay, that one. What do we got? 9 minus 5. Stop that. Okay, what about the middle element? 6 minus 15.
-9.
Oh my Lord. My arm's sore already. I'm not going to use this already. Who's that? I got to teach periods 1, 2, 3, 4, 5 today. It's craziness. Okay, what about this one? Oh yeah, much lighter. Go. 2 minus 9.
-.
Okay, this one down here. 3 minus 10. This one down here. 2 minus 20.
-.
And finally, root 4 minus 12. Okay, I replaced each element with its cofactor. Now, if you're not gonna pay attention to what I'm teaching you here, then your only other course is to use the ABC method, which is, but it works. You just gotta do more. Okay, now watch what I'm gonna do. Now I'm going to transpose this matrix. Now what the heck is that? Transpose means interchange the row and column numbers. Or an easier way to think about it is, you see this first row? The first row now becomes the first column. The second row becomes the second column. And the third row becomes the third column. So what you gotta do, replace each element with its cofactor, transpose it, and finally, the last step to find the inverse is to go 1 over the, just like over here, 1 over the determinant. So 1 over the determinant of this, the original matrix. So Chan, you said you can do it in your head. Go. Determinant of this. I think I got it. I think it's negative 37. Can somebody confirm that?
I don't know. I got the 10.
Okay, same thing, negative 34. Wait, that can't be right.
Isn't it negative 20?
Negative 16. Wait, let me try again. Huh? Minus, wait, negative 17. Negative 27. Okay, is that right now? Okay, there. That's the inverse. Yes, it's shorter, but you still gotta do work. So you rather do the A, B, C, D, E, F, G, H, I, or you rather do that? I think this is better. Now, of course, I'm not gonna give you this, but can you imagine what you would have to do to find the inverse of a 4x4? Replace each element with its cofactor. That means you have to compute 16 3x3 determinants. Anyway, somebody went to college, one of my former students, and they took linear algebra. Like if you're going to major in engineering, that's, of course, a lot of it is matrices. They said their final exam, they had to find the inverse of a 6x6 determinant. That was the one problem. That was the whole final exam. That's crazy. What? It's just computation? They said something about it was all or nothing too. Or you could just use the ABC method. You're going to run out of alphabets. Only got 26 alphabets. Then you got to do something else. Okay, and then the last problem on tonight's homework. Remember I told you on the second quiz, there's going to be, I'm going to give you 7 equations, 7 variables. You're going to use your calculator to solve it. The answer is going to come out to a phone number. You tell me what the phone number is, you get bonus points. So there's a problem just like that on tonight's homework. So practice on that, because that problem is on the second quiz. I think tonight's homework is just 5 equations, 5 variables, I think. I'm not sure. You can, so, yeah, would you just try it on your calculator and see what you get? If not, you got to tell me. Oh my gosh, how am I going to make it through today? Okay, we're finally done.
Oh, he sent it. I know, I was like, oh, he's not answering.
Oh, wait, no, the other kid is on.
Okay, we'll see you tomorrow. Don't forget to report to the lower gym tomorrow morning. Good luck. Tomorrow.
Do you know what we need to know about vectors for the AC?